and start sharing. Okay, so I'll put on the chat on the other one so that I can see what you write, and let's go. So Geng 200, and today is the first day of the shortest month of the year. And before we start, I have two announcements. The first announcement is about quiz 2. Quiz 2, which is gonna be on Wednesday. Wednesday, February 3 or 3rd. And
Doctor?
Yes, you have two quizzes on Wednesday?
Yeah, we have to, some of us have two quizzes. I have two quizzes on Wednesday.
Yeah,
so can I make it late?
No, that's fine. Just focus on what we will be talking about today, and you should be fine. You don't need to study. It's about today's lecture.
What time is it, Doctor?
During the class. Quizzes are always during the class. Covers today's lecture.
Doctor, how many quizzes will you count finally?
5 out of 6 or out of 7, depends. If I give 6, I'll be best 5. So it's always best 5 out of 6 or out of 7.
Okay.
Today's lecture mainly f of x, capital F of x, and mu. Announcement 2 is about the midterm. Midterm, as we mentioned, the syllabus, the midterm is going to be on March 1st. And once the timing is confirmed, I will let you know about the timing and the location. We are targeting 12:30 to 2 p.m. on this Monday. Okay. All be available during this time because there are no classes in this slot. So today, what we are going to do today, we're going to do discrete, random variables, characterization. We started last time. We'll continue today. And I'm not sure if time will allow, but if time allows, we'll do families, or we'll start the families of random variables, of discrete random discrete random variables. Someone saying what exam talk about? If you are talking about the announcement, don't please no quiz. You felt it. I don't know. Okay. So if you have exam during the time of this lecture on Wednesday, it's your problem to not to get the quiz. Okay. Right. Remember from last time, please, as I said, the quiz depends on your understanding of today's lecture. So make sure that you fully understand today's lecture so that you can do the quiz on Wednesday. طيب احنا we
Doctor,
started
the
to,
coming Wednesday.
yeah, the day after tomorrow we have a quiz. Yes.
Can you make it on to the next week? We have already 4 quizzes.
Yeah, it will be 5 now with this.
Okay,
شباب
thank
خلاص
you.
يعني يعني it's we every other week يعني on average we'll have a quiz. So يعني we have 1 week. Well, the quiz does not need to study, as I said. If you focus today on what we will be doing, I guarantee you'll get 10 out of 10. So don't worry about having more than 1 quiz. Quizzes are not a big deal. At least in this course. Maybe in other courses it's a big deal, but this course is not a big deal. Recall that a random variable is a function. Remember we talked about this, that maps the sample space S to the real line or part of it. It can map for discrete random variables, for sure it maps S to the integers or a set of integers. And we said that random variables can be discrete or continuous based on their ranges, based on what they are characterizing. And the general rule that we mentioned before, usually for the things that are counted, we have discrete random variables. For the things that are measured, we have continuous random variable. So, and the question was how to characterize random variables. And we started last time by the first way of characterizing random variables, which was probability mass function, which we write it as small f of x. And we talked last time about the properties of f of x and the definition of f of x, which so it's defined, if you recall from last time, f of x is the probability that x equals x. And always recall, we use capital letters to denote the random variable name, and we use small letters to denote a specific value of the random variable. So the probability mass function, by definition, is how we distribute the variables. What's the probability of 1? What's the probability of 3? What's the probability of 5? So we distribute the different probabilities on the different numbers, and we define it as small f of x. And properties that we should always remember that f of x is a probability, right? It's the probability that x equals x, which means f of x is always positive. Cannot have a negative f of x. And the second important property is summation over all possible values of f of x. This should give you a total of 1. So again, you can think of f of x as how we distribute probabilities over all x's. Let's do an example and see how What do you mean by this? We have a factory producing semiconductor wafers, and you go and test wafers for contamination. If you know those semiconductors, the chips that they manufacture, they usually manufacture them in like wafers, and then they start cutting them into chips. So this process is very delicate process. So it's done in clean rooms, and there should be no contamination. But still, sometimes there happens to be some contaminations in those wafers. And what you know is,
Doctor, could you please explain what is a semiconductor wafer in the first place?
yeah, you don't need to understand the details, but if you know those chips that fill your computer or fill any electronic device, you have those small chips. So those are manufactured usually in larger portions, and then they are cut. So each one of those will be inside one of the chips that you have it in your motherboard, in your desktop, or in your laptop. So these are made from silicon.
Processor?
Yes.
Okay, it makes sense. Yes.
So,
What do you mean
so
by
what-
contaminations? Like what kind
contaminations like dust from the air or any kind of particles that can get into those, and it will like ruin all the wafer. You have to discard it. It has contamination. So
Come on.
your room, or the room that you are working in was not that clean. Okay. So what we know is the probability in a certain factor, the probability that a wafer has large contamination is 0.01. So every time you take one and test it, the chances that it's a bad one or it has large contamination is 0.01. And the experiment is you go and test wafers until you get a bad one, and then stop. And I will define my random variable x as the number of tests till you get a bad wafer. So what will be the sample space of this
1
experiment?
until infinity.
Yes, you need at least one test.
One test, infinity.
Or 2, or 3, or 4, or 5, all the way to infinity, right? One test means the first one you test is a bad one. 2 comes from if you have a good one first and then a bad one, right? Then you stop. 3 means you have a good, and then bad, and so on. 4 is good, bad. So if I ask you to write down the probabilities, what's the probability? What's f of 1, which is the probability that x equals 1? Is what?
1 over infinity.
1 over infinity. So the probability that you go to this factory and you test the wafers, and the first wafer you pick is bad one is 1 over infinity, which is 0. This will never happen.
1%.
1 over 2, maybe good or bad.
It should
No,
be
I'm
1
telling you,
over 100, I think.
you have to use the information that I gave in the question. I'm telling you the chance that anyone randomly selected wafer to be a bad one is 0.01. I'm telling you the probability of bad.
0.01.
So yes, so to have the first one as a bad one is 0.01. How about f of 2? F of 2 by definition, probability that x equals 2. What does x equals 2 means? Means that the probability that the first is what?
It's good.
And
0.01 squared.
is
Still
bad.
the same, I think.
Let's do it. Yeah, just steps for this one, and then we'll do the rest easily. So, and again, we assume all wafers. We have very large number of wafers, and they are all independent. Then this is the
Same answer.
probability of first is good times the probability that the second is bad, because they are independent. So and means intersection. Intersection means the product. What's the probability that the first one is good?
0.99.
0.99.
No,
Yes.
I think
So
it should be 1 because okay, never mind. Sorry, it's
okay.
0.99.
So the first one is good is 0.99. The second one is bad is 0.01, and so on. What's f of 3? I will not do it in detail. So probability of x equals 3. So it's 0.99 times 0.99. Second one is good, and then the third is bad. And in general, f of x in general, which is the probability that x equals small x. What's the probability that x equals any number?
1.
It means that no, why 1? It means that you will have good x minus
Doctor?
1 number of goods followed by a bad one, right? So if x is 10, probability of x equals 10 means you have 9 goods and then 1 bad. Probability of x equals 100 means that 99 are good and then followed by 1 bad. Always understand the experiment. The experiment here, you will go and keep testing until you get a bad one and then you stop.
Doctor.
Yes?
Okay, I understand that the sum of all probabilities should eventually be 1. But my question is now in the first part, that's why I got confused. I think that the probability of the first one is good and the second one is bad. In this case, I think we should consider the probability of the first one as 1, is 100, because we are totally sure that the first one is good.
No, we are not sure. These are possible scenarios that we want to calculate the probability of each scenario. So if you do this experiment, you may stop at the first.
So we are assuming these results before we do the experiment?
Yes, we anticipate, we calculate the different scenarios that might happen. These are the different scenarios and their respective probabilities. So if 1,000 of you went and do this testing, each one will get one of those x's.
Then shouldn't the number of probabilities decreases with the number of times we do this experiment?
It is decreasing. I checked.
No, it's not
because it's the first time it's 0.99, the second time is the same as the first time.
There is no rule that says it should increase or decrease with time. It depends on the experiment that you are doing. Here, the probability that you will do it one time is 0.01, right? The probability that the second time is 0.99 times 0.01, because you are looking for, you will stop at, I understand, yani one of you said it should decrease because we are multiplying numbers that are less than 1 every time. Yeah, from that angle, it's fine. But in general, this should not be the case. This is just for this specific scenario that we are considering. But what matters is, when you add all of those, they should add to 1. according to the probability. So in general, this will be 0.99 to the power x minus 1 times 0.01, because each good will give you 0.99 and each bad will give you 0.01. So now I can ask you, probably not in the quiz, but in a homework, and on Wednesday, most probably I will ask you this question. I will give you an f of x and I will ask you, is this a valid f of x? Is this f of x valid? F of x, can anyone come and tell me I have this f of x that is probability of x equals 1 is 0.2 and probability of x equals 3 is 0.5, and how do we check that a certain f of x is a valid f of x? What we need to check are the properties that we started with, which are this one. And so to check if a certain probability is a valid probability, first one, check if f of x is greater than or equal to 0. So let's check. What's my f of x? F of x is given by, now we know the equation, x minus 1 times 0.01. And we know that x is 1, 2, 3. So now, can f of x be negative with this scenario, with this equation and these possible values for x?
No.
No.
No, what you can say is that substituting possible values of x in f of x will always result in positive number, right? Which means condition 1 is satisfied. Next, second condition we need to check. What?
Could it equal 0?
Can be 0, yes. The condition says greater than or equal to 0.
But one of the conditions says that the sum should equal 1.
Yeah, that's what I will do next. Check if summation of f of x equals 1.
But doctor, how can it equal 0? Can you give us like one example?
The probability that a certain event equals 0. Probability that you throw a dice and your experiment, you want to find that if the output is an even number. And then what's the probability that x equals 1? You are interested, your experiment is to have, no, this is not 0. You throw 2 dice, and you observe the summation of the output. What's the probability that the summation is 1? X equals 1 at the output.
Impossible.
Impossible, so 0. Okay. Summation of f of x should add to 1. So here you need to prove summation from x equals 1 to infinity of 0.99 to the x minus 1 times 0.01. You should prove that this should be 1. How do you prove this? So 0.01 goes outside, so this is 0.01 times summation from x equals 1 to infinity, 0.99 to the x minus 1. And I think, if I'm not mistaken, I don't have the solution with me, but if you have a series like this, this is equals 1 over 1 minus 0.99. Well, this is, if you have summation from I equals 1 to infinity, a to the power I minus 1, this equals 1 over 1 minus a, if a is less than 1. So this will be simply 0.01 times 100, which is 1. Go and check this yourself. But again, if I give you this question in the quiz on Wednesday, I will give you like a small f of x, which you can check easily that it's a valid or not valid f of x. So in this case, yes, this is
Doctor,
yes. Yes, go ahead.
Doctor, I have two, three small questions from the start of this question.
Yes, go ahead.
Doctor, from where did you get to know that the possibility of one of them being defective is 0.01?
This is given in the problem.
This is
The
known
people
from prior
usually they know
experiments.
this. They know this from history of this factory that usually 1% of its products are contaminated. So that's how they usually get it.
Okay, and Doctor, F P of 1 basically means what's the probability that this is defective, right?
What's the probability that you need to test only one wafer to get a defective one, which means that the first one you pick is defective.
Okay, clear. And Doctor, as you test more wafers, the probability goes down.
No, this is not, probability will not go down. Because as I said, we assume we have infinite number of wafers. This is what we'll be talking about probably on Wednesday. We call this Bernoulli trial. Bernoulli trial is a trial that in which the probability to have something or not to have it will not change as you repeat the experiment. So usually if you are producing millions of those wafers, then probability will not change. Okay?
So this is only done if you have infinite trials to be done.
No, you don't need to do infinite trials. You just need to assume that you have infinite number of wafers and you have this probability of being bad, 0.01. And then you do the experiments as many times as you want. Okay. Let's do another example, similar to the one that you might expect in the quiz on Wednesday. So I'm giving you this f of x. I'm not telling you about the context of the experiment. I'm just telling you that my f of x is given by this equation, and then 1, 2, 3, 4. And now I can ask you, is this a valid f of x? So again, what do you need to do? You need to check two things to check that they are all positive. So you need to find f of 0, f of 1, f of 2, f of 3, and f of 4. What's f of 0? You just substitute x equals 0.
1/25.
1/25. What's f of 1? 3/25. What's f of 2?
1/5.
5/25. What's f of 3? 7/25. And what's f of 4? 9/25. So we know that all greater than or equal to 0. So condition 1 satisfied. What's the summation? Summation is 1 plus 3 plus 5 plus 7 plus 9/25. So this is 25/25. Then this is 1. So this is a valid f of x. Okay. So you need to check two things. It's positive and they add to 1. One of them is not enough. So if I give you some probabilities that are negative and some probabilities that are very large, when you add them, you will get 1. So the second condition is satisfied, but the first condition was not, because you cannot have negative probability. So be careful. Okay. Right. The second way of describing random variables is the cumulative distribution function. And we call this capital F of x. and it's defined as capital F of X is, instead of defining the probability of a single point, now we'll talk about the probability of a range of points. So the probability that X is less than or equal to a certain value that you are interested in. Like probably in the first problem that we did, I can ask you, what's the probability that X is less than 3 trials, less than or equal to 3 trials? So this includes 2 trials, 1 trial, and 3 trials. And this is the definition of capital F of X. So let's continue with the example that we did. Let's continue with the example with F of X, which is 2x plus 1 over 25, where X is 0, 1, 2, 3, and 4. And let's try to find what's capital F of 0. Capital F of 0, again, by definition, is the probability that X is less than or equal to 0. So how many points are included in this range?
One only.
Only probability of X. So this is simply probability of X equals 0, which is 1 over 25. Type. How about if I ask you what's F of 1?
Doctor, can you repeat the line, the last line?
What's the probability? What's F of 0? You go to the definition. By definition, capital F of 0 is just the probability that X is less than or equal to 0. And I know that X has only those values. So probability of X less than or equal to 0 includes how many numbers of possible values of X? It has only 0, right? This is the only number included in this range, less than or equal to X.
Yes, okay. Yes, makes sense.
Okay. Type. For the 1, it's probability that X less than or equal to 1, which includes what?
1 over 25.
Yeah, X equals 0 plus X equals 1. So 1 over 25 plus 3 over 25, which is 4 over 25. Again, what's F of 2? Probability of X less than or equal to 2. Again, here you have probability of X equals 0 plus probability of X equals 1 plus probability of X equals 2, which is 1 over 25 plus 3 over 25 plus 5 over 25, which is 9 over 25. And so on. You can do F of 3 right away. F of 3 is 0 plus 1 plus 2 plus 3. So if you do it, you'll find that this is 16 over, is it 16? 16 over 25. So you have 8, 9, and
Yes, 16, Doctor, 16.
16, okay. And F of 4, since now you are including all of them, you will find that this is 25 over 25,
27.
which is, no, it's 1. You cannot go beyond 1. And this is what we are going to mention. And we are going to plot capital F of X to better understand what does it mean. So properties of F of X. The first one is that F of X is less than or equal to 1, greater than or equal to 0, because it's a probability. And the second condition that will be clear very soon, if X is less than Y, then F of X is less than or equal to F of Y. So remember, yeah, I will explain it. Remember that f of x, you can look at it as is like moving
Why?
from, yeah, I will explain, just wait. It's like moving from left to right, or from minus infinity to infinity, and adding probabilities as we move. Again, what does that mean? Let's plot small f of x and capital F of x, and then I will come back to this condition because it's some of you seems they did not understand it. So the best way is to plot both f of x and capital F of x. Let's plot them for the same example. So this is x, this is small f of x. So I have 0, and then 1, then 2, then 3, then 4. So for small f of x at 0, it was 1 over 25, right? At 1, it was 3 over 25. At 2, it was 5 over 25. At 3, it was 7 over 25. And finally, at 4, it was 9 over 25. Okay? It's just dots. And you don't need, by the way, you don't need to plot. If you don't want to have these vertical lines, you can just plot the circles of the f of x. So f of x is easy to plot. Let's see how capital F of x will look like.
It will be as a curve.
Okay, let's see. This is capital F of x. Again, this is 0, this is 1, this is 2, this is 3, and this is 4. Always when you want to plot capital F of x, we start from the left and we go all the way to the right. Okay, you start from left and you go to the right. So let's see. So when I am here, again, remember also what's f of x? For this example, what's the probability that x is less than minus 1?
0.
0, right? What's
Yes.
the probability that x is less than minus 0.5? 0.
Also 0.
All the way. You keep moving until, so to plot f of x, move from left to
Zero.
right. Every time you find a probability, you jump. So at 0, there is a probability, right? At
Yes.
0, there's a probability of 1 over 25. So you jump to 1 over 25. And then you continue moving horizontally. If you are not adding probabilities, you move horizontally. Once you face a probability, you jump. So at 1, what do you have?
Do you jump here at 4 over 25?
Yes, you add to what you have. So you already have 1 over 25. Now you will add 3 over 25. So you jump to 4 over 25. Again, continue moving till you get to the 2. And the 2, you add 5 over 25 to the 4 you have. Then you jump to the
9.
9 over 25. And then you continue until you reach the 3. 3, you'll add 7.
16.
7 to the 9. So you jump to
16.
16 over 25. and then you move till you reach 4, and in 4 you jump to
1.
1, and you continue to here. You continue to
Doctor,
yes.
if we have a question which the probability could be not only an integer number, could also be like 0.5 or something. It will be like a curve, right?
For what, when we talk about discrete random variables, you will always have your capital F of X as a staircase, what we call a staircase.
Okay.
When we go to continuous, yes, it will be a smooth curve, both the small f of X and the capital F of X. Okay, so let me just write here that this is not to scale. I'm not plotting to scale, so that when you plot, but this is the way to plot f of X. So now I can ask you a few questions.
Wait, Professor, this is for the f of x when it px is less than the other x, right? It's not the other.
Yeah, I will come to this. I will come. Don't worry. I did not forget about x less than y, then f of x less than f of y. I will come to it. But first, let me ask you, what's f of minus infinity?
Minus 1.
0.
0.
Don't tell me. I don't want to ask about a probability and you give me a negative number, please. Capital F of X is a probability. So at minus infinity is 0. It's always 0, regardless of which function you give me for small f of X. Always capital F of X at minus infinity starts from 0. And where it ends, where does it end?
1.
You always keep adding probabilities. You keep adding probabilities until you reach 1. Type. What is, if I ask you, what is f of 0.5?
I think in this case
1
it does
over
not exist.
25.
1 over 25, yeah.
Yeah, so this is 0.5, right? What's the value of the function? 1 over 25. What's f of 3.5?
16 over 25.
This is 3.5, right? So
16 over 25.
16 over 25. So note that capital F of X is a non-decreasing function. شو معناه? What does it mean? Meaning, as it increases, you either stay as you are or you add probability. So as we move from left to right, either we go straight or we jump because of adding probability. And this is why we have this condition. So if y is to the right of x, then you are sure that either they have the same f of x or that of y is greater than that of x, if y is to the right of x. Because capital F of x, it's not always increasing, but it's always non-decreasing. It will never go down. So I remember in one of the exams or one of the quizzes, I gave them this something like this, a function that looks like this. Sorry. A function that looks like, so it's end at 1, starts at 0, and I asked them, is this a valid capital F of X?
No, it's not, because it's decreasing at one point.
Yeah. So because of this, and this is not valid f of x.
Doctor, it is okay if it was at the negative side, right?
Hmm?
The left side.
Yes, x itself, the value of x itself can be negative. The x itself, this is x, right? So x itself can be negative, but f of x is always above the line. F of x is always positive. But x, yes, and I can give you another example. X is, yani, another example. And you can have f of x can be given like this. So this is x, this is f of x. X can be for -1, probability is 0.3. At 0 is 0.2. At 3, it's 0.5. So this is okay. This is a valid, right? This is valid.
No,
F
it
of x.
decreases.
They are always,
yeah.
no, this is small f of x. So this is all positive f of x. They add to 1. And then when you plot capital F of x, how does it look like? Capital F of x at -1, you jump to 0.3, and then at 0, you jump to 0.5, and then you continue to 3, and you jump to 1. So this is valid f of x. Okay. Final note on capital F of x.
In the graph there is a capital Fx, but in the let's say in the table it's small fx. Doesn't matter.
No, this is small f of x, and this is capital F of x. I did not
Okay.
plot small f of x. You can plot it if you want.
Okay, tamam.
Okay. Final note, if I ask what's the probability of x greater than x, so this is simply, you find it through the complement, which is probability that x is less than or equal to x, which is 1 minus f of x. If I ask you on this latest example, what's the probability that x is greater than 0? Greater than 0.
0.5.
It's you can greater than 0, then it's in this range. So either only the 3 is included, which is 0.5, or you add 0.2 plus 0.3, which is 0.5. So 1 minus f of 0, which is f of 0 is 0.5, and this will give you 0.5. Okay. Fine. Let me take the absence really quick, and then we move to the mean and variance. Okay, so you are L02, spring L02. Please log into your Blackboard to check in your attendance. I'm still it's loading. So start check-in. I started. So you'll have one or 2 minutes. It has 3 minutes, but you have 1 or 2 minutes to do it. Then I'll continue with the lecture. Oh, sorry, this is whenever I leave my iPad, it stops the sharing. Okay, Shabab, one minute remaining or so, 1 minute 20 seconds. Please don't tell me that you couldn't do it. Okay. So up to this point, we talked about two ways of describing the random variables. We talked about the small f of x, and we talked about the capital F of x, and we are left with two other ways that we'll do them quickly, which are mean and variance of a random variable. And let's start with the mean. We also call it mu, and also we write it as or expected value. Write it this way. Expected value of x. So how do we define it? Like we defined small f of x, we defined capital F of x, we define also mu. So defined as we define it as summation of x times f of x over all xi. So this is the definition of the mean, and as you will see when we do the example, this is very simple definition. So simply to get the mean, and I assume you all understand the mean is like defines the center of the random variables, or
The average.
The
point
average.
which most of the points are closest to this point. So to get the mean, just multiply each value of x by its probability and add. The mean, of course, reflects. Mean is, we call it when we start the statistics part of the course, mean is one of the most important, what we call, measures of location. It tells you the location of something. The mean of something tells you the location. And of course, it's not the only way to get the location. We'll talk about, when we come to the statistics part, we'll talk about other terminologies like the median, which is different than the mean. So the mean reflects the location of the random variable.
It's usually in the middle, right?
If it is a symmetric random variable, it's in the middle. If not, as we will see in this example, we'll see where it will be located and what's the physical meaning for the mean. So example, find the mean, again find the mu of f of x, which we talked about a bit earlier, where x equals 0 to 4. So we know that by definition mu is summation of x f of x. So if we have, so we have 0 1 2 3 4. So let me x f of x 0 1 2 3 4, and we have 1 over 25, 3 over 25, 5 over 25, 7 over 25, and 9 over 25, right? So to get the mean,
just a comment that your voice is extremely faster than your writings.
my voice is faster.
Yes, انت لسه بتكتب على فكرة هلا the other column of the.
No. It's only you, Ibrahim. For me, it's
والله؟
good.
Okay, I'll refresh.
Yeah.
No.
Okay. طيب. So take each value and multiply it by the probability and then add. So simply 0 times 1 over 25 plus 1 times 3 over 25 plus 2 times 5 over 25 plus 7 times 3 times 7 over 25 plus 4 times 9 over 25. So this is the way to do the mean. This is, you're expected to be able to do this on Wednesday to find the mean of a random variable that I give you. You just multiply each value by its probability. 1 second. So in this case, this will give you 70 over 25, which is 2.8. Yes.
Is there any specific value that usually the mean should be close to, or it's fully relied on the question?
It's depends on the values of x and their probabilities. But to understand the mean in a better way, you can look at it as, assume you have a bar, and you divide your bar, and here our random variable is between 0 and 4, right? So assume like you have, this is 1, this is 2, this is 3, and this is 4, and assume that you brought weights. So at 4 you put a weight of 9 over 25. So let's use different color probably.
Like the center of math and physics.
Yes. So this is 9 over 25, and then you put a smaller weight over 3, which is 7 over 25, and then a smaller one, which is 5 over 25, and then even a smaller one here, 3 over 25, and then very small one here, 1 over 25. Then your mean is here. You can balance this bar at 2.8. So where is the location of the mean? It's closest to the highest probability, because 3 and 4, they have high probabilities. So the mean should reflect that, because when you generate these random variables, most of the time it will be 3 or 4, right? These to be 3 or 4 have higher probability than to be 0 or 1 or 2. So the mean will be closer to the probable values of the random variable that we are talking about. Okay, so this is the mean. How about the second one, which is the variance? Variance is, we call it a measure of variability or spread of a random variable. So basically, it tells us how spread or wide are the random variables realizations or values. Okay. Let's define it and then see what does this mean. So it's defined as So we call it sigma square, the variance, or sometimes called V of x, variance of x. So it's defined as expected value of x minus mu square, which is simply summation also over all xi's. So now instead of multiplying x directly by f of x, you take each x, you subtract mu from it, you square it, and then you multiply it by f of x. And also you can show that this is equivalent to xi squared f of x minus mu squared. So this is the definition of the variance. So for the above example, so what is sigma square for the above example? Let's use this equation, maybe it's easier. So we know again that this is the table that I will be dealing with. So 1 second, Abdullah, let me write this down and then I will come to you. So you take each x, the first x is 0 squared, and then you multiply it by its probability. And then, so this xi, and then you take 1 squared times its probability, and then you take 2 squared times its probability, and then you take 3 squared times its probability, then you take 4 squared times its probability, and then you subtract the mean squared. And when you calculate this, this will give you the variance of the random variable that we are talking about. Yes, Abdullah.
I already found the answer. Thank you, Doctor. Clear.
Okay. طيب. Another related measure is what I'm sure you heard about it, is the standard deviation. Sigma. And it is the square root of the variance. So sigma or STD is just square root of the summation of xi squared f of xi minus mu squared. Again, sigma is also a measure of spread of a random variable. Let's do a quick example. Let's see. Example.
Doctor, what is the value which if sigma is close to, then the spread is less?
It depends on the random variable, honestly. Yani, a sigma of 1 for one random variable is large. If we talk about the noise, if you say sigma of the noise reflects the power of the noise. طيب? So if you tell me the sigma of the noise is 1 watt, this is huge. But if you tell me in your exam, for example, or in the quiz, the sigma for the student grades, so the grade was like 75 average, or expected value of the average was 75 out of 100 or 80 out of 100, then standard deviation or sigma is 1. Sigma is 1 means more or less that 60% of you scored between 79 and 81. You are very close to the mean. So if in your class, in your midterm, if I have students who scored very low, yani 10, 15 out of 100, 30 and then student who scored very high, 90, 95, then the average will be 60, right? But the variance will be very large. However, if most of you scored between 60 and 70, or 70 and 80, between 60 and 80, most of you, then the average is still 70, but the standard deviation will be small, like 10. The previous one will be 20 or 30. So it depends on the random variable. So usually, standard deviation or variance, we compare the same random variable in different settings, so that you have an idea what to compare to. So let me do this example real quick. I can also give you, in the quiz, probably on Wednesday, I will not give the variance, only the mean, small f of x, capital F of x, and the mean. I probably will not ask about the variance. عشان some of you have 4 quizzes, so I'm very kind.
دكتور والله ما بقصر دكتور صراحة يعني.
لا I know الكويز أنا بصراحة ما يعني I don't take other quiz in consideration. لأنه quizzes يعني you should not يعني ما بدي أقول you don't study, but based on this, as I said, based on this lecture, if it is not this lecture, I'll tell you exactly what to study. So it's a matter of half an hour maximum of study. So let's assume this is f1 of x, and this is f2 of x. So f2 I have at 5, I have 1/2, and at -5, I have 1/2. What's the mean here? What do you expect the mean? So the mean, you can calculate it, or you can, by looking, this is a symmetrical random variable, so it's 0. But if you want to calculate it, it's 1 times 1/4 plus 0 times 1/2 plus, this is -1, sorry, it's -1. -1 plus 1 times 1/4, so it's 0. What's mu2 here? The mean of this random variable? 0, right? سكتوا انتوا فجأة.
It's also 0. Yes.
-5 times 1/2 plus 5 times 1/2, which is 0. So I have 2 random variables. Both have the same mean. But which one do you expect will have a larger variance?
2.
2. Why? Why 2 has larger variance?
Because the space is larger. The gap
because, yes, it's spread away. It's spread away. So calculate sigma 1 and sigma 2. You will find sigma 2 is greater than sigma 1. Okay, very quick notes. Can the mean mu be negative?
No.
The mean can be negative?
Yes.
Yes. Because it depends on the location of the random variable. Depends on the location of a random variable. So if all values of the random variables are negative, the mean will be negative. Type. Can the variance or standard deviation be negative? Can sigma square or sigma be negative?
No.
No.
Because of the root.
Of course, no. Yes. It's from intuition, it's a measure of variability. So the lowest variability you can have, or the lowest spread you can have, is 0. All the points are on the mean. And from math, by definition, this is the definition. So you know that f of x is always positive, and you have this that is squared. So you are multiplying two squared, a squared entity which is always positive by a positive. This will give you a positive number. So spread is always positive. Smallest spread is 0. Okay. Fine. So that's it for today. We'll see you on Wednesday, inshallah. Be ready for the quiz and enjoy the rest of your week. Any question? I'll be around for a couple of minutes. If you have questions.
Thank you, Alex.
Thank you.
Sure.